All right, so hopefully you finished the table in 3A and figured out that indeed the frequency does seem to impact the value of our investment. In other words, the more we compound, so as n gets bigger and bigger and bigger, the more money we make. But hopefully you notice something really important. The significance of the amount of growth definitely starts to taper after a while. I mean, it was really obvious when I jumped from annual to quarterly that it jumped like a lot of money. Like $80, that's a significant amount of money. Most people would look at that and say, ooh, yeah, that's significant right there. But as you start to go through things, notice it doesn't really keep growing as drastically as we would hope. By the time you get down to the difference between compounding hourly and compounding by minute, the difference is 2 cents. And yet, if you looked at the frequency numbers, hourly means that the bank makes 8,760 payments to you in the course of a year. Compounding by minute means the bank is making 525,600 payments to you. I mean, that's obnoxious. Think about how much extra work the bank is doing to pay you by minute. I mean, it's all automated now, don't get me wrong. But think about the computing power and all of the programming necessary and all of the refresh opportunities that banking app that works for your money is going to have to make 525,000 times a year. Every single minute it's going to be refreshing and paying you more money so you can get a 2 cent increase. You can probably tell that banks are not really a fan of that amount of extra work on their behalf. Programming their software to pay you 525,000 times instead of paying you 8,000 times is significant work on their end just so you can get an extra 2 cents. And I'm sure the argument is, well, Herbert, it's free money. I should be getting as much free money as I possibly can. Yeah, but banks are also practical. You're one customer, and they have millions and millions of customers. Are they really going to want to put in all of the extra coding and all of the extra maintenance on all of their servers to make sure that every single person can get 525,000 compounds a year just so everybody can make an extra 2 pennies? It's probably not going to happen. So, realistically, what we should be taking away from this is the rate of growth is still positive, but it's significantly less dramatic by the time you start compounding by ridiculous increments. By minute, by second, by nanosecond, you can probably tell the rate of growth is going to slow down significantly. And compounding by minute is not going to end up being that different than compounding by second, which is not going to be that different than compounding by millisecond or nanosecond or anything ridiculous. You're basically going to end up with $14,918 no matter how much you divide up your year, no matter how many times the bank kicks you the money. Because at that point, the bank is dividing your interest rate into such tiny little pieces, you're not getting much. That's the thing. You kind of hit the point where the bank is dividing up your money into such teeny, teeny, tiny little increments that they're not making a big difference anymore. They're too small to make a difference. So that's the moral of the story. And the reason why I want you to know that is because of questions like letter B. The bank is going to offer this guy an additional optional fee, $100 a year. He can have his interest rate compounded every millisecond. I mean, doesn't that sound appealing? If this guy took Algebra 2 and maybe slept through like half of the class, but remembers that one day we were talking about interest, and remembers that one time that he goes, oh, yeah, Herbert said the more often they compound, that's better. It's always better the more often you compound. Compounding every millisecond, that sounds great. I'll totally do that. Here, bank, take my $100 a year. Think about it. If he's going to compound every millisecond, he's probably only going to make a couple extra cents. Is it worth spending $100 to the bank so that they can give you back a few extra cents? I don't think so. The mathematically advantageous answer would be no. Don't bother doing that because you're going to waste like $99 on an unnecessary, appealing, but mathematically insignificant calculation And why would you do that? You're throwing the money at the bank for them to do something where they're probably sitting behind the scenes like, sucker, because they know that it's not going to pay off. You're going to give them an extra $100 so they can give you back an extra couple of pennies in return. It's not worth it. And that's the kind of critical thinking that is so important to understand when we talk about these compound interest problems. In real life, we're going to deal with situations like banks and salesmen and people who are going to try to tell you, oh, this is the best deal for you. We'll offer this special deal just for you. And you have to be careful. Not everybody is trying to take advantage of you, of course, but sometimes you just have to critically think and you have to be aware. You have to think about the numbers. You have to calculate some things for yourself and not just take somebody's word for it, to verify that if they're saying it's a good deal, that it really is and that the numbers match up. Because sometimes situations like this happen where we get taken advantage of for a deal that sounds good in theory, but when we delve a little bit deeper with the numbers, proves to be absolutely a ripoff. So think about those ideas for a second, just kind of let that all marinate. And then in the next question, we'll start to put together a more practical way of thinking about this compounding in a way that you'll actually see realistically come up in real life.